Hi everyone and welcome to our basic electronics tutorial class. Today we're going to start with a simple resistor. There are two symbols that you will see of resistor in a circuit. Sometimes it's also called impedance. Impedance is general term or generic term for all resistors, whether DC resistance or reactive resistance, they call it impedance. But these are the two basic symbols you will see in most electronic circuits. Let's go straight to simple simulation. Right here, you're going to see a voltage source, 5 volts to be precise. There's a switch right here to close the circuit, so I'm going to leave it open right now. And then you can see a complex or hybrid resistor network on the right hand side. So why don't we just switch the position of these two resistors? We have one that is called the load and we have R7. I think this makes it look better. So let's go ahead and analyze this circuit. Okay. All right. So I have R1 and R7 in series, but R7 is parallel to R load. Right now, I'm gonna get R load out of the circuit. So just by removing this connection, I have just R1 and R7 in series. What we know about resistors is when they are in series, the equivalent value is the summation of both resistors in that circuit. So right here I have 100 ohms plus 200 ohms. This load will see exactly 300 ohms. If I close this circuit and run a simulation, I will get a value that is equivalent to 300 connected across a load of 5 volts. According to Ohm's law, V is equal to IR. So let's look at Ohm's law. Ohm's law says that V equal to IR, where I is the current flowing through the circuit and R is the impedance or resistance in our case here. Alright, and of course you know that power is I squared R or IV. Now the circuit we have here is going to produce a certain amount of current flowing through the series resistors once the circuit is closed. So the amount of current will be the value, the quotient of 5 divided by 300. So let's close the circuit and find out. So we'll close the circuit and we'll run a simulation. And we'll see 5 volts is developed across the series arm, but the current flowing through it is 16.667 milliamps. That same current is going through the entire series arm, but the voltage developed across each arm is different. The voltage developed across R7 is 3.333 volts, whereas the voltage developed across R1 will be the difference between 5 and 3.333. So that will be 1.66667 volts developed across R1. This satisfies our assumption or assertion that Ohm's law is obeyed in this circuit configuration. V is equal to IR. So this is a law. This is a basic law in electronic circuit theory, that V is equal to IR. The product of the current and the resistance in a circuit, in a path in a circuit, is equal to the voltage developed across that resistor. So we have proved that here. Now, what we're going to try to do is to connect a more complex network across this load. And by saying this, all we're going to do is just connect another resistor in parallel with the load or with the R7. And this new resistor is, we're going to call it our load resistor. Before I go ahead with this, let me tell you something about resistors. What are the values of resistors or the functions? Sometimes we use them to provide voltage division. So in a circuit where you have 5 volts but you have some sections that require less than the supply voltage. You can use resistor network to provide voltage division to set the voltage that goes to that arm of the circuit. For instance, we want the load to consume only 3 volts or a portion of our circuit. Just assume this load is a section of your circuit that you're building, and that section requires only 3.33 volts or 3 volts. You can use this resistor configuration to do that. Some Arduino circuits that you have will require 3.3 volts. Some of them will require 5 volts. If you have such and you have a 5 volt source, now easily you have seen what you can do. You can use two resistors of one value twice the other. It doesn't have to be 100 ohms. It could be 1000 versus 2000. It can be 4000 versus 8000. Whatever value you get twice that size. The important thing here is the ratio. Once the ratio is 1:2, the voltage will be divided in that order as well. So now, what do you think is going to be the voltage across the load? Let's take another voltage ammeter, voltmeter ammeter, and connect it across the load and see how much voltage will develop there. When we run this simulation again, we're going to see the voltage across the two arms, the R7 and the load, is 2.5 volts each, and the current through each one of them is 12.5. The reason being that the load value of the load the load is equal to the R7, the value of R7. So right here we'll see equal voltage, equal current going through them. All right. So that has proof. We have the proof right there. And what happens if I have different values? If I increase this value, what if this value is less? What if my load is half the value of R7? What if R7 is half the value of R load? Let's try that, because we have the two impedances in parallel are exactly equal. What happens? So let's do another simulation. Remove this resistor and change the value here. Let's make this value 100. When I run this simulation again, I get 2.5 volts and 25 milliamps. And this 2.5 volts is out of 5. That tells you that the other 2.5 is developed across R1. So both of them, they share the voltage dropped across each of them is equal. Alright, so what if I connect this load back? So let's see what happens when I connect the load back. If I connect the load to the R7, just like we did before, what do you think is going to happen here? Let's run the simulation right now. Okay, before we do that, I want you to know that the value, when resistors are in parallel, the equivalent resistance of that path tends towards the lesser of the two. If there are 3 or more, then it will tend towards the least value in the system. So the equivalent resistance here will be less. At worst, at best, will be around 100, but it will be less than 100. And when they're in series, the equivalent will tend towards the bigger of the two. So if we run the simulation here, you will notice that the voltage developed across R7 and the load is less this time. It's 2 volts. Why? Because the value of these two is less than 100 when they're in parallel. How to calculate resistance in parallel is that the R equivalent resistance is equal to the product of all the resistors in that network divided by the sum of the resistors in that network. So in this case, it will be 100 multiplied by 200. That gives us 20,000 divided by 100 plus 200. That will be 300. So 20,000 divided by 300. The value will be around 66.666, or you can just round it off to 67. All right, so that will be the value you get here. So this value is less than the value of R1, and that's why the voltage developed across the load and R7, that parallel network, is less than the voltage dropped across R1. Now I want you to look at the right side of this circuit and try to calculate Let's remove some of this to make it clearer to see. Now try to calculate the equivalent resistance of this network, R4, R5, and R6. R4 and R5 are in parallel and R6 is in series with them. The clue is to solve the parallel part first and then solve the series. So get the equivalent of R4 and R5 and then add it to R6. That will give you the total resistance by this circuit. Now, I want you to use that and replace the circuits to the left. Replace everything here by that equivalent circuit. So right here, I'm going to just remove this load, the R7, and then also remove the load. And then that equivalent resistance will go from, will replace R1. So you're going to call it R equivalent now. So let's close the circuit. This is what you're going to have. And this will not be R1 anymore. You're going to call it R equivalent. I want you to find your R equivalent. The value, I'm going to put lots of ones because this system will not accept laters. But so I want you to calculate your R equivalent. All right. And put it in your comment section, ask your questions, and I'll be able to respond to you. We're going to be going from basic resistors, simulations and circuits to capacitors and inductors and transistors. We might be switching it up from time to time. We're going to do bipolar transistors and MOSFETs, and we're going to go to ICs, and we're going to go to a little bit of programming. We're going to look at Arduinos and basic Raspberry Pi, and we're going to build some circuits from basic to advanced. So please subscribe to my channel. Let your friends know about this channel. I have another channel called HecaNet where I have other videos, other tutorials on electronics. But this is going to start more organically from basic electronics, and we build up gradually. So if you're a student, you know someone who is a student who is trying to be an electrical engineer or electronic engineer, this would be an opportunity for them to learn from a former student. And I'm still learning I'm still in a live school right now. I've done the regular academic school to the level that I could go, but I'm still learning, and I'll be teaching all I've learned over the years of more than 20 years of being into this electronic field. From my time in high school, I'll be teaching some of the secrets and giving you some of the clues that I've gathered over the years, and I have some tips and some clues and some best practices, that will help you to learn and memorize circuit designs and with ease. And you should be able to, if you're a student and your first year, I'll be able to teach you to be able to design your own circuits, your own project by the time you graduate. This is very important. So you be an engineer for real, the one who does the job, who does the real engineering, not just being an engineer for the sake of being one, but you'll be able to be practical in your approach. You should be able to design your circuits and analyze them and understand them, and you should be able to build from basic building blocks. I'll teach you when we get to basic electronic circuit like transmitters and all that. I'll teach you from the basic block diagrams what you need to do and how you need to go about it. And hopefully we've learned a thing or two about resistors, how you can use it to provide voltage division. So keep watching out for more videos from my channel, and if I get a lot of subscriptions and a lot of comments, I'll be encouraged to make more videos. And if you have anything in particular in mind that you want to learn about, you can put it in the comment section, and we'll try to accommodate that when the time is appropriate. All right, thanks again for watching. I'll see you in the next one. Bye.